Okay, welcome. Today we're going to talk about compound interest, which is an exponential growth function. So make sure you have your notes out. Make sure you also open a quick response form. You're going to need to answer a few questions. And remember during the video to pause it to keep caught up, and also stop the video and rewind sections you don't understand. Sometimes it takes a few times going through them for it to sink in. All right, compound interest. Exponential growth functions are used in real-life situations involving compound interest. Compound interest is interest paid on the initial investment. We call that the principal. It's the amount we start with, we put in, we deposit. Compound interest is also paid on any previously earned interest as well. And that's different than simple interest, which strictly pays interest on what you put in each time. All right, so here's the key concept. Go ahead and pause the video and write down the formula in your notes. Make sure you identify all the variables, the A, the P, the R, the N, and the T. And when you're done, go ahead and start the video. Okay, compound interest. Consider an initial principal P deposited in an account. That's money we put in. I'm going to deposit $400 or anything like that, anything you put in the bank. And the account pays interest at the annual rate R, excuse me, and remember with R is expressed as a decimal. Anytime we deal with percentages, we always do math with a decimal, and it's compounded in times per year. The amount A in the account after T years is given by this equation. So if you didn't quite get your A, your P, your R, your N, and T, they're all up in here. Okay, moving on. I'd like you to pause the video, and in the quick response form, I want you to find the following words in your own words. Principal, the A in the formula, the R, the N, and the T. Make sure you put that in box 1. Again, that's box 1. And when you're done with that, start the video back up. Okay, here we are, example 5. This is find the balance in the account. So you deposited $4,000 in an account that pays 2.92% annual interest. Find the balance after 1 year if the interest compounded with the given frequency. So part A, we're going to do quarterly, which is a quarter, 4 times a year, and then daily, which is 365 days a year. All right, starting with the A. With interest compounded quarterly, the balance after 1 year is, let's take a look. So the first thing we want to do is write the formula down. We always want to write our formula down because it's easier to substitute, we make less errors. So A is equal to P times 1 plus R over N, all to the N times T power. And the next step is to identify all our variables. First thing we need is identified as our P, and our P is our initial amount. It's our principal. So there's our P. We need the R. There's our percent. How much is the interest rate? And remember that R is equal to 2.92%, but we move the decimal over 2 spots. So that would be 1, 2, which would lead us to 0.0292. We need our N, how many times a year? Well, it's quarterly, and that equals 4. And there's our N. And our T is going to be 1 year. And our T is also up here. So identify all our variables, and then it's just a quick substitution. Here's your P, your R, your N, and this is your N times T. So just with identification and quick substitution, and now you're going to have to do some math, and remember your order of operations as you do your math. Remember that we have to divide before we add, or before we do the exponents, do the parentheses first, and you're going to need a calculator on this. So 0.292 divided by 4 plus 1 is 1.0073. Type. We need a calculator. 4 times 1 is 4. And after our simplification, one more simplification is to take your 1.0073 to the 4th power, again calculate a problem, and then multiply by 4,000. And the result is 4,118.09. And that's the end of the year balance. So you deposited $4,000. By the end of the year, with the interest being compounded 4 times, you end up with $4,118.09. Okay, so you can see it's just a quick substitution, identification, substitution, and calculator. Let's take a look at another one. Let's take a look at the daily. Now, process is still the same. Write down the formula. Identify all your components, your P, your R, your N, and your T. And for this particular problem, we're using the same P, the same R, the same time, T. The difference is N, the number of days we're compounding. Okay, so the previous problem, we took interest 4 times a year. It means we took interest on 4,000 the first time, made a little money on that. The second time, we took interest on the second balance, and then the third time on the third balance, and so forth. This time, we're going to do it every day. We're going to take the interest every day on the balance we have. So here we go. Identify, plug it in. Again, this is calculator. P, R, N times T, and remember R is a decimal. With simplification using the calculator, we get 4,118 and 52. So the balance at the end of 1 year is 4,118.52, just a little bit more than if we did it 4 times a year. Now, it doesn't seem like much, but if you did this over 20 years or 50 years, then the money adds up very, very quickly. Okay, what I'd like you to do is one more problem for me. I would like you to do the guided practice problem. You deposit 2,000 in the account that pays 4%. Find the balance after 3 years for interest that's compounded daily. I'd like you to work this out and submit it into box 2 in your quick response forms and submit that to me.